Welcome to this explainer. Today, we're going on a seriously mind-bending ride, starting from a simple ancient riddle and pushing all the way out to the absolute outer limits of human knowledge. We're going to explore the strict boundaries of what we can actually understand about the universe and, well, ourselves. It's a fascinating journey through philosophy, math, and quantum physics. And as you'll see by the end, these seemingly unrelated fields all end up crashing headfirst into the exact same intellectual roadblock. Let's dive right in by asking a deeply foundational question, one that has kept thinkers up at night since the dawn of civilization. Is there anything out there that we as humans absolutely cannot know, just as a matter of principle? And I don't mean because we haven't built a powerful enough computer or a massive enough telescope yet. I mean, is there an inherent structural limitation hardwired into human thought itself? It's a huge, profound question. Let's see if we can unpack it. Section 1. The mystery of paradoxes. To answer that big question, we really have to start by zeroing in on a concept that has completely resisted centuries of attempts to unravel it: the paradox. Now, a paradox isn't just a simple mistake or a math error, it's an actual structural limitation where we find ourselves kind of stuck, suspended between way too many good answers. Think of it like a glitch in the matrix of logic. If you look at the pieces in isolation, they seem completely logical, but put them together simultaneously, the whole thing becomes totally absurd. A brilliant, classic illustration of this is the liar paradox. It's just 3 little words. I am lying. But watch what happens. The liar tells the truth only if he lies, which breaks the fundamental rules of common logic in a single sentence. Just think about it for a second. If the statement is true, well, then he's lying, making the statement false. But wait, if the statement is false, then he's not lying, which makes the statement true. It is a perfect, inescapable, infinite loop. Seriously, don't think about it too hard or your brain might literally short circuit. Okay, so because of maddening loops like this, humanity basically split into 2 camps to try and explain what on earth is going wrong here. The big debate is, are paradoxes a real feature of the universe or just a bug in our human brains? On one side, we have the realist view. They argue that paradoxes actually exist out there in the real world, that reality itself is built on tensions and contradictions. On the flip side, the constructivist view says, no way, the universe is perfectly fine. They argue that paradoxes are strictly products of our own flawed human thought and our reliance on imperfect senses. Section 2. Gödel and human limits. To figure out which of those 2 camps actually hit the nail on the head, we have to look at the hard mathematical limits defined by the legendary Austrian logician Kurt Gödel back in 1931. His work was an absolute game changer for how we understand truth. Gödel proved, beyond a shadow of a doubt, that within any deductive system, there are true statements that simply can't be proven using that system's own internal rules. Imagine you're writing a rulebook for a board game. Gödel proved you can never use that rulebook to prove the rulebook itself is perfectly flawless. If a statement is true, you can't always demonstrate its truth without stepping completely outside of the system. So what's the crucial takeaway here? It's that paradoxes aren't just frustrating dead ends. They're actually the friction that happens when a less powerful cognitive structure collides with an emerging, more powerful one. You see, Gödel showed us that the human mind's power to generate knowledge seems essentially infinite. But, and this is a big but, we can never devise a single closed box to perfectly contain or prove all of it. To prove these seemingly unprovable truths, we are forced to build a new, broader metastructure. We literally have to think outside the box we just finished building. Section 3. The quantum reality clash. Now, let's take this idea of colliding cognitive structures and apply it to the most massive structural collision in modern science. Right now, physics is completely torn between 2 entirely different worlds. On one hand, you've got the predictable, cosmic macro world of general relativity. Think of it like a perfectly timed, majestic clock, operating with an absolute constant speed of light, causality, and a passive observer who's just watching the universe tick by. But on the other hand, you drop down into the micro world of quantum theory. And guys, this is basically a chaotic mosh pit. It embraces non-locality, where things seem to affect each other instantly across space, superposition, intrinsic randomness, and an active observer who actually fundamentally changes the outcome of an experiment just by looking at it. This quantum universe defies our normal physical intuition so deeply that the Nobel laureate Richard Feynman actually issued this famous, slightly exasperated warning to his fellow physicists. He basically said, look, if you try to map your everyday common sense understanding of reality onto the quantum world, you're going to end up in a blind alley. The math works brilliantly, yes, but the underlying reality it describes is completely alien to us. As he so perfectly put it, Nobody knows how it can be like that. The absolute ultimate clash of these two domains has to be the 1935 thought experiment of Schrödinger's cat. It is arguably the most famous and for sure the most stressed out imaginary feline in all of science. Now, Schrödinger didn't design this to show how much sense quantum mechanics makes. He actually designed it to show how completely absurd it becomes when you try to scale those microscopic rules up to our everyday macro world. Here's a quick refresher on how the paradox works. A quantum system, like a decaying particle, can theoretically exist in two superimposed states at the exact same time. So the theoretical cat stuck in that box, whose life depends on that tiny particle triggering a poison valve, must, according to the math, logically be both alive and dead simultaneously, right up until the moment we open the box to check. Now, as physicists, we can easily accept a mathematical formula existing in two states at once. But a living, breathing cat? That is exactly where our everyday, common-sense cognitive structures violently collide with quantum math. Over the years, science has desperately tried to resolve this puzzle with a whole bunch of alternative interpretations to escape this weirdness. We've got the many worlds interpretation, which suggests the universe literally splits into parallel realities every single time a quantum event happens, spawning an infinite number of branching timelines. Then there's the hidden variable interpretation, arguing we just don't have all the information yet, and there's a deeper deterministic reality humming along underneath that we just can't see. And there are several others, like the disturbance model or advanced action interpretations. But here's the kicker. All these attempts end up creating profound interpretational problems of their own. None of them cleanly lift the fog from the quantum universe. Section 4. The Trap of Dualism. So we really have to ask ourselves, why is this schism so incredibly hard to solve? Why can't we just find a nice, neat mathematical bridge between the cosmic and the quantum? Well, it turns out the problem might not actually be the math. It might be the way we think. We are kind of stuck in this ancient, dualistic intellectual tradition that unnaturally separates the human observer, the subject or the knower, from the passive physical object being observed. Imagine classical physics as a scientist standing safely behind a one-way mirror, assuming they can passively watch reality without changing it. But quantum theory completely shattered that mirror. It showed us that the knower actually actively produces the outcome of the experiment. Because quantum theory essentially forces the subject back into the equation, it implies there's a special absolute frame of reference out there, the observer. And that completely shatters Einstein's beautiful rules of relativity, which clearly state that no frame of reference is special. This deep contradiction left legendary physicists like Paul Dirac completely unsatisfied. He realized that fully embracing the quantum observer meant betraying the fundamental spirit of relativity. As he said, it's the best we can do, but we cannot be content with it. Section 5. Bridging the physics divide. But despite this looming philosophical nightmare, physicists haven't just thrown their hands up in defeat. They've tried some incredibly creative ways to stitch reality back together. Let's explore one fascinating mathematical attempt to bridge this frustrating gap. Back in 1986, a physicist named John Cramer tried to unite these worlds by visualizing complex quantum processes as this multi-step invisible handshake between particles. He proposed that an emitter sends an offer wave forward in time, and the observer evaluates it and sends a confirmation wave backwards in time. This cycle repeats, echoing back and forth, until all the conditions are perfectly met, and this bizarre cosmic handshake is completed. It honestly sounds super elegant, right? But there is a major catch. To avoid breaking Einstein's strict speed of light rule, because otherwise these confirmation waves would essentially be communicating faster than light, Cramer had to claim this handshake happens completely outside of physical time. And well, that just creates an entirely new set of spatial paradoxes. If an event happens outside of time, it appears instantaneous to us here in the real world, which basically breaks the rules of relativity all over again. It's an absolutely brilliant effort, but it remains trapped in the exact same contradictions. Section 6. A new way of knowing. So, if all these mathematical models keep failing to unite the macro and the micro, perhaps the universe isn't what's broken here. Perhaps our dualistic way of thinking is. We might actually need a fundamental shift in our underlying philosophy. To move forward, we have to recognize the universe not as a bunch of disconnected, isolated parts, but as a deeply connected, continuous process between the knower and the known. Ever since the early modern period, science has relied heavily on an atomistic approach, breaking things down into smaller and smaller isolated pieces. But quantum theory is screaming at us that the subject and the object are actually dancing together in a continuous process of construction. Which brings us to one final, truly mind-bending thought to take away from all of this. If the rigid barrier between the observer and the observed is just an illusion, and if reality cannot be completely separated from the human minds that are observing it, then what exactly is truth? Are we simply wandering around discovering reality, or are we, in some deep, fundamental way, constricting it together? I'll let you chew on that one for a bit. Thank you so much for joining me for this explainer, and keep questioning the limits of what you know.